Hi friends, today we can discuss assignment model. In this session, I am planning to take basic introduction of assignment model, mathematical model of assignment problem, various solution methods of assignment problem, Hungarian methods for solving assignment problem. In all my operations research classes, I am using the following book as my reference, J.K. Sharma, Operations Research, Theory and Application, 6th edition. Assignment problem is a particular case of transportation problem where the resources are assignees and the destinations are activities. Given n number of persons are available for doing n number of jobs in such a way that each person can do one job at a time, though with varying degree of efficiency. This is a case of one-to-one assignment. For example, suppose we have 3 individuals as my employees and we have 3 different jobs. So each person will be allocated for a single job. And vice versa, each job will be done by a single employee. This is the basic concept of assignment model, one-to-one assignment. And this technique, assignment technique, are very useful for the allotment of workers to various machines, salesmen to different sales areas, clerks to various checkout counters, classes to rooms, vehicles to routes, contracts to bidders, etc. Mathematical model of assignment problem. A general data matrix for assignment problem is shown in this table. Similar table we have seen under the transportation model also. That's why the data matrix is the same as transportation matrix, except that the supply of each of the resources and the demand at each of the destination is taken to be 1 due to the one-to-one assignment. We have seen in this transportation model, this is supply side and the demand side, we will have different numbers, but in this case that won't be applicable. Let Xij represents the assignment of resource I to activity j such that Xij will have 2 values, either 1 or 0. If a resource I is assigned to an activity j, then the Xij value will be 1, otherwise the value will be 0. So the mathematical model can be stated as a linear programming model. So the minimize z equal to summation of I equal to 1 to n, summation of j equal to 1 to n, Cij into Xij, where Xij is the decision variables and Cij is the cost of assignment of resource I to activity j. So this is subject to the following constraints: sigma j equal to 1 to n, Xij equal to 1 for all resource availabilities. Similarly, summation of I equal to 1 to n, Xij equal to 1 for all j activity requirements. And Xij, as we mentioned earlier, its value will be either 0 or 1 for all I and j. Solution method of assignment problem. We can solve assignment problem by any one of the following methods. One is enumeration method. In this, a list of all possible assignments among the resources and activities is manually prepared. Then an assignment that involves the minimum cost is selected. If 2 or more assignments have the same minimum cost, in that case, in such problem, we'll have multiple optimal solutions. This method is unsuitable for manual calculations when n is large. Suppose if you have 10 or more employees and jobs, then it will be very difficult for calculating optimal solution by this enumeration method. Simplex method. This we have learned in the linear programming problem area. If we have two or more decision variables, then we will use simplex method for solving such problem. So each assignment problem can be formulated as a 0 or 1 integer linear programming problem. Such a problem can be solved by the simplex method. The general mathematical model of assignment problem involves n by n decision variables and n plus n equalities. For example, if you have 5 employees and 5 jobs, then we will have, if we are going to solve by simplex method, we will have 5 by 5, 5 into 5, that is 25 decision variables and 5 plus 5 equalities. If n is large, again, then solving such an assignment problem manually by simplex method is very difficult because it will consume a lot of time and effort. And the third method is transportation method. Assignment problem can also be solved by MODI method. A very basic feasible solution of a general assignment problem that has a square matrix of order n should have n plus n minus 1, that is 2n minus 1 assignments. But due to the special structure of this problem, this assignment problem, none of the solutions can have more than n assignments. Consequently, solutions will be degenerate. So the procedure for solving is computationally inefficient. And the fourth method is Hungarian method. This is an efficient method of finding the optimal solution of assignment problem without making a direct comparison of every solution. This method works on the principle of reducing the given cost matrix to a matrix of opportunity costs. Opportunity costs show the relative penalties associated with assigning a resource to an activity. This method reduces the cost matrix to the extent of having at least one zero in each row and column so as to make optimal assignments. So this is an efficient method. So we will go deep into this area for solving assignment problem. Hungarian method for solving assignment problem. The various steps for solving an assignment problem by Hungarian method will be described in the following area with the help of an example. So clearly understand the question, then we will discuss each step along with solving the problem. A department of a company has 5 employees with 5 jobs to be performed. The time in hours that each man takes to perform each job is given in the effectiveness matrix. How should the jobs be allocated? 1 per employee so as to minimize the total man hours. So this is the given matrix. We can see there are 5 jobs A, B, C, D, E and 5 employees 1, 2, 3, 4 and 5, and all the given numbers are the time taken by each employee to do each job. For example, the first employee, if he is assigned to do for job A, then he will take 10 hours. If he is allocated for doing job C, then he will take 10 hours. Similarly, all the other numbers as follows. So this is an effectiveness matrix. for this particular problem. With this, we will start each steps. The step 1 is develop a cost matrix from the given problem. So in this case, in this given question, we have 5 jobs and 5 employees. So this is a square matrix, 5 by 5 matrix. So we can call it as a balanced matrix. In some cases, suppose we have 5 employees and 4 jobs, or 4 employees and 5 jobs. In such case, the matrix, the effectiveness matrix won't be a balanced one. In such case, we will make the given matrix into a balanced matrix by adding dummy rows or dummy columns with all the cost element as 0. This is the first step in Hungarian method. After this, we will find the opportunity cost matrix. So this is the original given matrix, cost matrix. From this, we will find the opportunity cost matrix by 2 transformations. Initially, row transformation and followed by a column transformation if required. So for that, identify the smallest element in each row of cost matrix and then subtract it from each element of that row. So from the original cost matrix, look into the first row, identify the smallest element here. So the 5 is the smallest element here. So subtract this 5 from all these elements. It will be like this. The value final result will be like this. 10 minus 5, 5. 5 minus 5, 0. 13 minus 5, 8. 15 minus 5, 10. 16 minus 5, 11. So the first row is like this. Similarly, after that we will go to the second row, identify the smallest element in that particular row, subtract it from all the elements. So in the second row, the element is 3. Subtract 3 from all these elements and value will be like this. Go to the third row, identify the smallest element, which is 2. It has been appeared 3 times, no issues. So subtract that 2 from this particular row. So it will be like this. In the fourth row, the smallest number is 7. Subtract it from all the elements. So the answer will be like this. In the fifth row, the minimum smallest element is 4. Subtract it from all other elements. Value will be like this. After doing this row transformation, we have to do the same similar concept in column wise also. In the reduced matrix obtained from this row transformation, identify the smallest element in each column and then subtract it from each element of that column. After doing this row transformation, we will go for column transformation. In order to get each column and each row will have at least one 0 element. So in this case, we will just check from this row transformation. We will go for the column transformation, but in this case, in all the columns we will have at least one 0 at this time itself. So there won't be any change from this matrix to this matrix. There is no change between these two matrices. Then in some cases, suppose in this question, here instead of this 2, the value may be some 5 or 4, then automatically by subtracting 2 from that, we will have a value here. So we should do this column transformation at that time only, otherwise no issues. Now this is the opportunity cost matrix. Ensure that after doing this row transformation and column transformation, all the rows and all the columns will have at least one zero. With this, we will move forward. Then we will start assigning this opportunity cost matrix with the following procedure. In the first round of making assignment, identify rows successively. As we have performed row transformation, the assignment will also start with the row assignment. So each row we will check. Identify rows successively from top to bottom until a row with exactly one zero element is found. Make an assignment to this single zero by making a square around it. Then cross off all other zeros in the corresponding column. Here in this question, so in the first row we have only one zero, you can see, so you just mark an assignment like this, a square around that particular zero. Now immediately after assigning that zero, you just check, is there any other zero element in the particular column? For the time being, there is no zero, so no issues. Go to this second row, identify the single zero. Only we can assign a row with a single zero. So here also one zero, you can see, assign here. Immediately after assigning that, you just check in this particular column, is there any other zero? Yes, we have a zero element here. So you just cross off that particular zero. Go to the third row. Now we have three zeros here. So you just skip for the time being. Go to the fourth row. Now we have only one zero element here. Initially we can see here two zeros, but already one zero element we have crossed off. So we have only one zero element here. So assign it like this. Immediately after assigning this, you just check in this particular column. Is there any other zero element? Yeah, we have one zero element here and we have one zero element here. So you cross both. So we have crossed off these two zero element. Now come to the last fifth row. Now we don't have any zero element in this particular row. So this row wise assignment is over. So the same thing we have to apply column wise also. So identify columns successively from left hand to right hand with exactly one zero element that has not been assigned. Make assignment to this single zero by making a square around it and then cross off all other zero element in the corresponding row. So in this first column we have one assigned zero. In the second column we have an assigned zero. In the third column you just see we haven't assigned this particular zero when we were doing the row wise assignment, because at that time we have seen three zeros here. So now we have only one zero in this particular column. You just assign this zero. Immediately after assigning this zero, you just check in this particular row. This zero we have already cancelled, crossed off. Now we have a zero here. So you just cross off this zero also. Now go to the fourth column. We have one assigned zero here. Go to the fifth column. Now there is no independent zero because the existing one we have crossed off. So there is no other zero element present. Now we can't do any more assignment in this particular cost matrix. So this is what mentioned here, second round of making assignment. And in here we have to identify, in some cases, suppose all these zero elements are coming here instead of here, this place, suppose this zero is present here. So in row wise assignment as well as column wise assignment we can't do anything, because in both situations there will be two sets of zeros. So in such case, that's why if a row or column has two or more unmarked zeros, and one cannot be chosen by inspection, then choose 0 element arbitrarily for assignment. In such case, we will choose any one of the 0 arbitrarily. Immediately once we select a particular 0, we can cross the particular column or row with other zeros, and then there will remain another 0. We will select that too. We have to repeat this process until such a situation comes. Now there is no more independent 0 element present. After doing this, we have to check whether we have reached the optimal solution or not. For that, we need to check how many assignments we have performed. So 1, 2, 3 and 4. In this case, we have 5 employees and 5 jobs. We should get 5 assignments properly. Then only it will be an optimal solution. So we have to check the optimality with all this condition. There will be 3 conditions. One condition we have mentioned. Suppose we have 5 columns and 5 rows. If we have obtained 5 assignments after this process, then we will reach the optimal solution. And the second criteria is, if a 0 element in a row or column was chosen arbitrarily for assignment. As I mentioned just before, suppose all these places are with 0 elements, then we have to choose any one 0 arbitrarily. Automatically we will cross off the other 2 elements and we will select the other one. So we will get a solution. That will also be an optimal solution. But in this case, we will get 2 pairs of optimal solutions. That is, there exists an alternative optimal solution. If there is no assignment in a row or a column, then this implies that the total number of assignments are less than the number of rows or columns in the square matrix. That means we haven't obtained an optimal solution. So we have to move forward. Like in this particular case, in our question, we have obtained only 4 assignments. We have 5 rows and 5 columns. We should get 5 assignments. So this is not an optimal solution. So we will go forward. Once we understood we have not obtained the optimal solution, then we will revise the opportunity cost matrix. The assigned cost matrix we will revise by inserting some vertical and horizontal lines. How we will draw these particular lines? For that, we have a particular procedure to mark these lines. So clearly understand this revising process by drawing horizontal and vertical lines with the following procedure. So here we have to clearly understand how we will start. You can see some tick marks here, some lines here, how we will draw all these things. For that, row wise, you just observe in each row you can identify a row with no assignment. So this is the 5th row which is not having any 0 assignment. So you start your tick mark from here. So mark this particular row. When we choose a particular row to mark, it will be on the right hand side of that row. Once we selected a particular row, immediately after that you just observe each element of that particular row. Identify, is there any 0 element, whether it is assigned or crossed. So we can identify, yeah, here there is one 0 element. So you just choose that particular column. So this is the second tick mark. You have identified one 0 element in that row and marked that particular column. Immediately after this, marking, you observe this particular column. Is there any zero is assigned? Yes, we have assigned this 0. So you mark this particular row. This is the third mark, tick mark. So now you have identified this row by observing this assigned 0. Once you put this tick mark, row wise tick mark, you have to observe the entire row. Is there any other 0 element present? Yes, we can see one 0 element here. So you just choose this particular column. Immediately after choosing this column, you observe, is there any assigned 0 element in this column? Yes, we have this 0 as assigned. So you just choose this particular row. After that, immediately after choosing this particular row, observe, is there any other 0 element in this particular row? There is no other 0 element. So our tick marking process is stopped. So until such a condition comes, you have to put all the tick marks row wise as well as column wise. After that, we have to draw the vertical and horizontal lines. The rule for drawing the line is, you draw vertical lines through the ticked columns. You have two ticked columns, so you draw the vertical lines here. For horizontal lines, you have to identify the unticked rows. That is, you have not chosen this row, you draw this line here and one line here. So this is the procedure for drawing the horizontal and vertical lines. After that, you just count the number of vertical and horizontal lines. Now we have only 1, 2, 3, 4. If the number of lines drawn is equal to the number of rows or columns, then current solution will be optimal solution. But in this case, you just see we have obtained only 4 lines. We have 5 columns or 5 rows. So we haven't obtained optimal solution. Therefore, we will go to the next step. In this 6th step, we have to develop a new revised opportunity cost matrix by the following procedure. For that, this is the revised cost matrix. Now we have to develop a new revised cost matrix like this with the help of the following procedures. The procedure is like this. After drawing these horizontal and vertical lines, we can clearly observe each element. There are 3 types of elements now. Some elements are like 6, 15, 3, 4, 2, 5, 5, 6, 8. These are not touched by any line. From that, you choose the smallest element. In this particular case, we can see the 2 is the minimum smallest element here. This 2, you choose this element 2. This is one category of numbers which is not covered or touched by any line. Some other elements like this 5, 10, 0 and 8. They are the element which is touched by 2 lines or in the section of 2 lines. And the other numbers are like they are touched by single lines, 0, 0. All other elements are touched by single lines. So these 3 conditions you clearly understand. From that, we are choosing the smallest element from the numbers which is not touched by any lines. Subtract that number from all the other such numbers. So this 2 is subtracted from 6, 15, 3, 4, 2, 5, 5, 6, 8. The result will be shown in the next matrix. The same 2 will be added to the junctions. So this 2 will be added to this 5 to get this number 7. Same 2 will be added to this 10 because this 10 is touched by 2 lines. So it will become 12. This 0 will become 0 plus 2, 2. This 8 will become 8 plus 2, 10. All the elements with the single line touching keep as such. There won't be any change in that numbers. So we will get a new revised cost matrix like this. Now we will start the assignment process from row wise. First row we can assign this 0. Now go to the second row, only 1 0 here. You just choose this 0. So we assigned this 0. Immediately after that we check, yeah, we have a 0 here, cross it off. In the third row, for the time being, we have 2 zeros. So skip this step. Go to the fourth row. Again, here also this 0 is present. So skip for the time being. Go to the fifth row. Only 1 0 element is here. You just choose this one. Once we assign this one, then immediately you just check in this column and cross this 0. Now start with the column wise. First column we have, second column we have assigned, third column we have 2 zeros. So we can't do. So you just skip. The fourth column we don't have, we have assigned this one. Now in the fifth column you can see only single 0. So you just assign this 0. After assigning this 0, you just check. Yeah, we have one 0 element here. Cross it off. So this column wise is over. Again you start with the row wise. First row assigned, second row assigned, third row, now the third row is assigned. Now the fourth row has only 1 0 element. You just assign this one. Fifth row is assigned. Now there is no column or row with independent 0 element. Now the assignment is over, and now immediately after that you just count the number of assignments. 1, 2, 3, 4, 5. We have 5 columns and 5 rows. We should get 5 assignments. Now we obtain that. Since the number of assignment is equals to the number of rows or columns, this solution is optimal solution. Immediately after getting this optimal solution, the final stage is to make an optimal assignment schedule like this. For that, we have this new revised cost matrix here. We will take our original cost matrix with the time elements. In this particular question, each workers to perform a particular job, the time consumption has been given. So that is the original cost matrix. So we will take original cost matrix and we will keep the assignment in that particular corresponding cells, corresponding elements we have assigned like this. From that we will make this assignment schedule. These 5 jobs, job A, B, C, D, E. First job is assigned to second person and he will take 5 hours to complete it. Second job is assigned to first person like this and he will take 3 hours to perform it. Similarly, for C, D, E, jobs will be allocated to 5th, 3rd and 4th employees and their corresponding time is 2, 9 and 4 hours. In total, by adding all this time, 5 plus 3 plus 2 plus 9 plus 4, which is 23 man hours. This is our final answer. Ensure that after getting the optimal solution from this new revised cost matrix, we are preparing such an assignment schedule. Hope you understood. Thank you.